Hello everyone. Today we are going to learn about how to define the bus connection operation of DSQC651 board. All the ABB standard I/O boards are devices hung under the device NAND field bus and communicate with the device NAND field bus through the X5 port. For example, we set the name of I/O board in the system to board 10. The bus connect to the I/O board is set to device NAND, and the address of the I/O board in the bus is set to 10. First, click the Main menu button in the upper left corner of the flex pendant. Select Control Panel. Select Configuration. Double-click Device NAND device. Click Add. Click the drop-down arrow corresponding to Use Volume Form Template. Select DSQC651 Combine I/O device. Double-click Name to set the name of DSQC651 board in the system. Set the name of DSQC651 board in the system to board 10. Click the page down arrow. Set address to 10, then click OK. Click Yes so that the definition of the DSQC651 board is completed. Next, let's look at the operation of defining the digital input signal DI1. Set the name of digital input signal to DI. Set the type of signal to digital input. Set the I/O modular where the signal is located to board 10, and set the occupied address of signal to 0. First, click the Main menu button in the upper left corner of the flex pendant. Select Control Panel. Select Configuration. double-click signal, click Add, double-click Name, enter DI1, then click OK. Double-click Type of Signal and select Digital Input. Double-click Assigned to Device, select Board 10. Double-click Device Mapping. Enter 0, then click OK. Click OK. Click Yes to complete the setting. The above is the process of defining the bus connection of the DSQC651 board and defining the digital input signal DI1. Next, according to above method, we define the digital output signal in the same way. Set the name of digital output signal to DO1, set the signal type to digital output. Set the I/O modular where the signal is located to baud 10 and set the address occupied by the signal as 32. The specific operation is as follows. Next, we define the group input signal. Set the name of the group input signal to GI1. Set the type of the signal to group input. Set the I/O modular where the signal is located as baud 10, and set the address occupied by the signal from 1 to 4. The group input signal is a combination of several digital input signals, which is used to accept the decimal number of the BCD code input by the peripheral device. In this example, GI1 occupies a total of 4 bytes in addresses from 1 to 4, which can represent decimal numbers from 0 to 15. By analogy, if it takes up to 5 bytes of the address, it can represent the decimal number from 0 to 31. The specific operations are as follows. Next, we define the analog output signal. The analog output signal is commonly used to control the welding power voltage. Here, we take the creation of linear relationship between the welding power voltage output and the robot output voltage as an example. Define the analog output signal A01. Set the I/O modular where the signal is located to baud 10, and set the signal occupying address from 0 to 15. The maximum output voltage is 40.2 volt. The minimum output voltage is 12 volt. The maximum logic position is 65,535. The maximum output voltage of the corresponding I/O board is 10. When the output voltage of the welding machine is maximum and the minimum output voltage is 0, the specific operation process is as follows.